We were speaking about sensors in ROS, and we are going to continue to do so. Let me show you here where we were. So not here, we were in part 10, sorry, forward. And now PSR, and now part 10, I think. Yeah, so we were discussing sensors. I believe that we did until exercise 3, actually until exercise 5. So for home, you were supposed to work on exercises 6, 7, and 8, right? So, yeah. Only did until 3? No, in the practical lesson, didn't I do? In the second class, I did a bit more. Okay, but I hope you did 4 and 5, okay? If you didn't, you can ask me for help if you have some questions, but I will start with 6, okay? So, actually, before starting with 6, today I bought some presents because it's Christmas. Well, these are not presents. I'm not offering anything. I'm just showing. But you can consider them presents. So we have here a couple of sensors which are very useful for robotics. And let's start with this. So this is it's called the Intel RealSense camera T265. So it's a camera like this. And one of the problems in robotics is when you have a robot, if it's a mobile robot, it needs to know typically to move around. And to move around means that you need to know where you are, where you want to go to, and then how to get there. These are the typical 3 issues that face a moving robot. So where you are, where do you want to go, and how to get there. The part about where the robot is, where are we, that's called localization. Okay, so localization is a problem of the robotic system being able to know where it is. It can be a relative localization if it knows where it is with respect where it was just some moments ago. That's relative localization. Or it can be global localization if it knows where it is with respect to the Earth coordinate system. For example, if you get a GPS position, that's a global position with respect to Earth, okay? But of course, robots work indoors, and indoors we don't have GPS. Furthermore, GPS doesn't give you enough accuracy. So robots have to find other ways to be able to understand where they are or where they are with respect to where they've been before. And this is called localization, as I've said before. And this is done not only, typically this is done simultaneously with the reconstruction of the scene. So we will do a bit more in the next classes, but this problem in robotics is very well known. It's called SLAM, simultaneous localization and mapping. And there are several solutions to do simultaneously the localization. So I need to know where I am now and where I'm going to be, where I was before. And then I'm also using this information to reconstruct the environment. This is done in a couple of ways simultaneously. This is SLAM, and we will work on SLAM in 2 classes or 3, I think. For now, I'm just going to show you the localization part. So Intel sells this device, and this device is special because it's not only composed of 2 cameras, it's actually composed of 2 cameras and a processor inside that is running an algorithm for localization. In this case, it's called Visual SLAM because the localization is based on visual cameras, RGB cameras. So these are 2 RGB cameras, and I'm just going to show you how easy it is to plug and play this in ROS. Because one of the other great things about ROS, I think I'm in number 25 already, great thing about ROS, is the drivers for the sensors. So for many sensors that are useful for robotics, we already have ROS drivers. And these drivers will be able to connect to the sensor in whatever connection the sensor requires, in this case USB, and get information from the sensor, in this case images, and because this is a visual odometry, a visual localization system, also the localization information, which is called odometry, and it will do that in the ROS ecosystem. So it will automatically publish all this information into the ROS ecosystem, and we can just take a look at it. So let's see how we can do this. So the sensor is plugged in. I can just turn on my code. And for this sensor, I just downloaded a package called RealSense. So I just sudo apt-get installed, and now all I need to do is something like this: ROS launch, RealSense. So I didn't develop this package, I just installed it. And you can see the demo T265. So what's happening here? What's happening is that this launch file, you know what a launch file is already, is launching several stuff. And you tell me, what kind of stuff is it launching? Well, that's a good question. Let's take a look at it. Oh, yeah, not this one. I want RQT graph, topics, visualization, introspection, node graph. Yeah, that's it. This is the same as RQT graph. So remember, nodes are ellipses and the topics are squares. So it's launching a node called RealSense 2 Camera, and then it's launching another node called RealSense 2 Camera Manager. This is because of something that I'm really not also you have RVs here, okay? Because it also launched RVs, as you can see here. I won't get into details about what's doing here. It's using nodelets, and nodelets are something special, which I'm not going to discuss now. That's why you have the manager there. But it's launching a node to talk to the camera, and it's launching RVs to visualize. What can we do besides this? Well, if this is in ROS, you already know that we can take a look at the list of topics. So these are all the topics that are currently being published, right? For example, you can see here that this system does not have only 2 cameras, it also contains an IMU, inertial measurement unit. That's an accelerometer coupled with a gyroscope and also with a compass, okay? So the system will be able to more or less get information about its attitude with respect to the vector of gravity. And well, we can do something like this: ROS topic, echo, camera, gyro, gyro sample. Okay, so this is the information that is coming out of the gyroscope. And if you move this around, in principle, that information should change. You can see that the angular velocity is changing, the vector of angular velocity, okay? So all these informations that are being published by the sensor are available as ROS topics. So that's one good thing about this already, because if we know ROS, we already can access all the data from the sensor without really having to study the API from the sensor. So I spent 5 minutes setting up the sensor, and now what I know about ROS is enough for me to work with the sensor. I don't have to study a new sensor over and over again, okay? Now, what is visual odometry? It's being able to localize. So how can I see if the system is being well localized? Well, I can show in RVs. The RVs was already configured because this is a demo. But you can see here, if I show the TFs, that we can see here a transformation. So X is forward, Z is up, and so on and so forth. So if I pick up the system, okay, I'm picking up the system, and perhaps this is not a good way. Okay, now like this. So it's facing you, right? And now, for example, if I go up, this is my point of view. Perhaps you would, okay, but imagine this is from my point of view. So going down, going up, going right, going left, moving forward, moving backwards. So this is really picking up my movements just out of inertial measurement units and images, okay? Rotating. So this is very nice for solving localization off the shelf. And you can also say, oh, but I would also like to see the images. So if there are cameras, there should be images available. Well, that's the question I did yesterday. And so I went and looked. So let's take a look at what we are calling actually. Okay. We are calling this camera demo, this RealSense camera demo T265.launch. So if we go there, so raw CD RealSense to camera, then CD launch, and then demo T265 launch. So what this launch file is doing is only including another file, which is called rs2t265.launch. So this launch file calls another launch file, okay? That's what this include means. And then, in addition to that, it calls the RVs node that launches automatically. So what I'm going to do is I'm going to do a copy of this file into my package. Actually, I did it before, so I'm just going to show you. Yeah, this one here. So I'm just doing a copy. And so my file is doing exactly what you see, what you saw below. It's calling the rs2t265.launch and then RVs. So calling rs-t265 and there are RVs. Now, what I did afterwards was to take a look at this rs2t265.launch. This is trava-língua. Tongue breaker. RS, yeah, you will. Yeah. Okay, so if I take a look at this file that was being called, you can see here that we have arguments for the launch file. In particular, those that I'm interested on are the enable fisheye 1 and enable fisheye 2 arguments. So that means that I can actually, you can see that by default they are false, so that's why I can't see topics for images. But if I turn them on, I will be able to see the images. So all I did was to create a new launch file where I set these two arguments to true. Okay. Now, instead of calling the original demo t265.launch file, I'm going to call my own, which sets up these two arguments. And let's see what happens. So ROS launch, my package is called part-exercise 9. So part-exercise 9. And now demo blah, blah, blah. Okay, so now if I run this, you can see that we will have additional information here. So now we have also the camera fisheye, camera info, camera fisheye image topic. So you have information about the camera itself, images. And in RVs, you can actually go and do something like this. Image. Okay, just one for now. So this is an image that we have to configure. So we have to say which is the topic. That will be fisheye 1. So you can see here image 1. Let me put it on the right. And now we can add a second image. So image. We are going to configure the topic. Fisheye 2. And I'm going to put it here. So these are the two images that the system has. If I change this, you can see yourselves, right? So these images are actually, these are my fingers, you can see them. These images are very wide. These are called fisheye camera lenses because they are so wide and they appear to be the eye of a fish, okay? Fisheye lenses. And any idea about the reason why they are using fisheye lenses and not regular lenses?
Has the bigger field of view.
Right? And how does that help?
It helps because you can get a better picture. It's like you can see everything that's in front of you.
Yeah.
So if you used to, you can see the whole area.
Yeah. Not really. So these two are actually pointing more or less to the same place. If you look at the image on the top and the bottom, they are more or less almost always pointing. Yeah, stereo system. So you don't really have, you have a lot of overlap. The reason why they are so wide is because if they were narrow, if the field of view was narrow, what would happen is that, for example, instead of seeing this, I would only see something like this in a regular camera. If I move my camera very quickly like this, from one frame to the other, you will not have overlap enough for the system to know how much it moved. So these are wide field of view so that if I move fast enough, it will not get lost because it will always have some overlap between the current view and the previous one. Okay, that's why they're using fisheye lenses. Okay, so you can see how easy it is in ROS. That's the key takeaway that I want to tell you. It's very easy to set up this camera in ROS. Now, let me unplug this one. And let me show you the next project. Perhaps. So next one. Next one is also Intel, and it's an RGBD sensor. Actually, they call it a LiDAR. So this is a dual sensor. Like the previous one, this is not a single sensor. We have two sensors here. In this case, we have an RGB camera, a standard one, not a fisheye one, an RGB camera, which is here, okay? And in addition to that, we have a LiDAR system. A LiDAR is, well, you know what a LiDAR is. You've seen data from from LiDARs. So you know how it works. It's just send light and then receive the echo or the reflection of the light in order to assess the distance to the objects. And so what we're going to do is try to make this also operate in ROS. Let me just perhaps, something like this. Now we have a cable. And where does this plug in? Okay, plug it in. And how hard is it to make it work? Well, let me show you. So this is called, I forgot the name, 515, I think, something like this. Yeah, L515. So, ROS launch, Real Sense, because this is also from Intel, Real Sense 2 camera. And now this is the demo. No. Where was it? Perhaps. I thought it was. I forgot. I did something. I launched this and I don't know. Yeah, perhaps the RGBD. Is it? Okay, let's take a look. ROS, well, ever, I don't think so. Let me see the history of my commands and grab 515. Well, 515, there's a lot of stuff. What is it? L515, right? Okay, bottom line, I don't remember how to launch this. So, ROS, how to launch, Intel, Real Sense, L515. Okay, so it supports L515. I've installed it already. So it's this spec for this type of camera. I'm just not seeing the proper launch file. Let's see again. ROS launch, Real Sense, camera. Yeah, it has to be. And now demo, point cloud, perhaps. I'm not sure. I don't remember what I did again. No. Is it? Oh, yeah, that's it. Okay. Ooh, low disk space. Okay, so what are we seeing here? Well, let's start with the basics first. So this is, yeah, so it crashed. My system crashed. It happened the other day. I don't know why. Well, it really crashed. I think it's with Zoom or something. I have to restart everything over again.